So guys, in today's video we are going to deal with a new important class of inorganic compounds which is called as ethers. What it is called as ethers. Okay, in the previous videos as we have seen, we have dealt with alcohols and phenols. And we came to know that to a compound or to an organic compound to be said as an alcohol, it should have a functional group as OH. Yes or no? Similarly, when we talk about your ethers, do remember their general representation is ROR. ROR. In many of the books, we say that the functional group of an ether, is actually O. Just O. The functional group is O. On either side of this O, whatever the substituents you will be having, they will be their respective alkyl or the aryl groups. But one important thing, in some of the other books, they also say that whatever the ethers we are studying, they're actually not the functional groups. Instead, they are just the substituents. So keeping both the interesting facts in our mind, first and the foremost thing, let us understand, what do you mean by this ethers? As I have mentioned, whenever we talk about ethers, their general representation is ROR. Okay? Then, once we have got to know what do you mean by these ethers, we have to understand about their classification. Yes. So basically, we are going to classify these ethers into mainly two important headings. Yes. One is called as your symmetrical ethers. And another is called as your unsymmetrical ethers. Of course, by the name itself, I hope some of the pupils have come to know what do you mean by this symmetrical or unsymmetrical ethers. Do remember guys, when I was talking about the ethers general representation, I have said that ethers are written as ROR. So whatever the symmetrical and unsymmetrical part we are going to study depends upon these alkyl groups. What does that mean? That refers to if on either side of the oxygen, I repeat, if on either side of the oxygen, whatever the two alkyl groups are present, if they are equal, then such type of an ethers are called as your symmetrical ethers. I repeat once again, if on either side of the oxygen atom, the two alkyl groups which are present, if they are equal, such ethers are called as what? Symmetrical ethers. Okay. Of course, now you can only define the unsymmetrical ethers. Can you please help me then? Okay. If on either side of the oxygen, if the two alkyl groups are not equal, such ethers are called as what? Unsymmetrical ethers. Are you getting my point? So general representation for symmetrical ethers, we write it as ROR. Whereas for an unsymmetrical ethers, we write it as ROR dash. So guys, now let us look after examples so that it would be clearly understand how can you differentiate between your symmetrical and unsymmetrical ethers. First, I will give you the example, then we'll see that how will you classify it. So first example I will be giving as CH3OCH3. What will you say? Whether it will belong to symmetrical ethers or unsymmetrical ethers. Alva. Of course, whatever the alkyl groups which are present over here, they both are same. So since both the alkyl groups which are attached to the oxygens are same, so they will be belonging to that of your symmetrical ethers. Similarly, let me take out one example. CH3O, CH2, CH3. So what is this? I can write it as how? CH3O, C2H5. So what I'm observing over here, one alkyl group is one, another alkyl group is another one. So that means both are different. So this will be an example for your unsymmetrical ethers. If I take one more example, CH3, CH2O, CH2, CH3. So what is happening? So this could be written as how? C2H5O, C2H5. So what we are observing over here, on either side of the oxygen we are having the same alkyl group. What I repeat once again, on either side of the oxygen we are having the same alkyl group. So it will also belonging to symmetrical ethers. If I write as CH3O, C6H5. So what is we are seeing over here? One is an alkyl group, another is an aryl group. So both are different. So now this will also belonging to that of your unsymmetrical ethers. Are you getting my point? So basically we saw that whenever we are representing an ether, we generally write it as ROR. And for an organic compound to be said as an ethers, we know that it should have an oxy group present over there. Then we came to know about its classification. Depending upon what type of your alkyl or the aryl groups are present on either side of the oxygen, we are mainly classifying your ethers as symmetrical ethers, unsymmetrical ethers. In symmetrical ethers, what does it says? If on either side of your oxygen, the present aryl or an alkyl group, okay, if they are same, then such ethers are called as what? Symmetrical ethers. If on the either side of the oxygen, if the present alkyl or the aryl groups are different, then such ethers are called as what? Unsymmetrical ethers. Are you able to see the difference? Okay. Now next let us talk about its nomenclature. So now let us look after the nomenclature. Basically guys, according to your syllabus, it is well known according to your PU syllabus. If you are well aware how to write the IUPAC system, it is quite enough. But when you are attending the competitive exams, you have to understand the four important types of your ethers. So what are those? First, as usual, the common name, how to write the common name for the ethers. Second, the IUPAC name. Third one, epoxy name. Fourth one, the cyclic ethers. So if you are knowing all the four categories, it will be quite good enough in order to solve certain reactions in your ethers for your competitive exam. So first let us talk about a quite simplistic examples of the common names. Common names, that how will we write the names of your ethers. So first let us take an example as CH3O, CH3. So as I have said earlier, according to this ethers concept, remember it is not a functional group. It is acting as a substituent. Okay. So we have to just observe that what type of the alkyl groups are present on either side. Since here whatever the groups which are present on the either side of the oxygen are same, then we have to look after what is its name in the common system. That is, when we talk about the common name of the CH3, what will be called as methyl. Similarly, this is also methyl. So how can I write it? Since there are two such methyl groups, I will be writing as a dimethyl. Okay, dimethyl. The overall system is what? Ether. Dimethyl ether. Are you getting my point? If the same scenario if I take for C2H5O, C2H5, then how can I write this? Yes, since what this system is called as what common name? Ethyl. Since there are two such ethyl groups, I can write it as what? Diethyl ether. Alva, diethyl ether. Are you getting my point? If I take an example of CH3O, C2H5, how can I write this part now? So according to the common name, this is called as what? Methyl, whereas this is called as what? Ethyl. I repeat, the common name for this part is your methyl, whereas this one is called as what? Ethyl. So when you are writing for an unsymmetrical ether in a common name, you have to follow the alphabetical order. Methyl means M it is coming. Ethyl means E is coming. According to alphabetical order, E comes first. So we will be writing as ethyl, okay, ethyl, then methyl, okay, ethyl, methyl, ether. Are you getting my point? Yes? Okay, very good of that. Now let us check out one more important thing. CH3O, CH, CH3 and CH3. Let me talk about this part. Of course, now this is what? Methyl. Yes or no? So this is my methyl, whereas this is my what? Isopropyl. Alva, isopropyl. So do remember, I would be writing it as what? Methyl, methyl, isopropyl, methyl, isopropyl, ether, methyl, isopropyl, ether. Let us take about one more important part. CH3O, CH2, CH2, CH3. What you can say it as? This is methyl. What is this one? It is propyl. So it is E, this is P. Which comes first? Sorry, this is M. Alva, methyl means it is M, this is P. So of course M comes first. So what will you write as? Methyl, methyl, propyl, ether. Are you getting my point how we are writing it? So whenever we are writing the common names, of course we have to just check out what type of an alkyl groups are present to it. If there are two same alkyl groups, then we have to use the Greek prefixes as di, like that, di, tri, like that. If they are different, then we have to arrange them in the alphabetical order. Is that clear? Now let us check out certain important another examples. Of course, some of here are solved in the earlier case, but here some others are also present. So what is this? CH3O, CH3. I am asking for the common names. Of course, it will be what? Yeah, please say dimethyl ether. Yes or no? Dimethyl ether. Whereas this one is, here is your methyl, here is your ethyl. As I said, you have to arrange in the alphabetical order. So ethyl, then comes methyl, then is our ether. Yes or no? What about this one? C2H5, C2H5. So it will be diethyl ether. Okay, this we have seen in my earlier examples also. But see this part, of course, now this is also an unsymmetrical ether. Well, wow, one R is not equals to R. So this is R, this is R dash. So how will you say? Of course, this is called as what? Methyl. So from methyl, first letter is what? M. Whereas this is called as what? Phenyl. Alva, it is called as what? Phenyl. So which will be coming first? Yes, methyl will be coming first, then phenyl, and then ether. So methyl, methyl, phenyl, ether. Yes or no? Methyl, phenyl, ether. Now this is one important class. See here, this is your CH3, CH2, which means ethyl. But when you are talking over here, how is it? You just observe it. Yeah, I can write it in this way also. So this is my benzene ring. Here is my CH2. Here is my O. And then C2H5. Overall structure can also be written in this way. But since I have written in elongated form, that's the thing. Nothing more changes. But what is the name of this compound? So don't get panic. You just observe what is the name, common name for such type of alcohols. If I write it as a CH2OH. Yes, we have studied about it. All the types of alcohols. So whenever a hydroxy group is attached to an sp3 hybridized carbon atom which is adjacent to that of your benzene ring, what it will be called as benzylic alcohols. So in general, since it was having what alcohol, I was calling as what? Benzyl alcohol. But if I am not having this alcohol, what this compound will be called as if it is having only CH2 group attached? Just CH2 is attached. Istu grouping na venante. This is called as your benzyl. This is called as what? Benzyl. Do remember. So this part, this much part. So what it will be called as? Benzyl. So this is called as what? Benzyl. Whereas this is called as what? Ethyl. So we are from benzyl we are having B. From ethyl we are having E. So according to alphabetical order, B comes first. So how can I write it? Benzyl, then ethyl, then comes ether. Are you getting my point? Benzyl, ethyl, ether. Okay. C6H5CH2. Okay. If I write in for molecular formula, how can I write benzyl? C6H5CH2. So this is part is called as what? Benzyl. So benzyl ka B comes first. So according to alphabetical order, benzyl, ethyl, ether. Okay. So what is this part? CH3C, CH3. How can this will be called as? Alva. So they are tertiary butyl. So this is one tertiary butyl. This is another tertiary butyl. So there are two such tertiary butyls. So di, yes, tertiary butyl ethers. Di tertiary butyl ethers. Are you getting my point? So what we are seeing here, the common names. So how to write the common names? You have to just see that what are the R groups are present in their common names. So just you have to use them. If both are same, then you have to use the Greek prefixes as di, tri, all those things. In case if they are different, you have to arrange them in the alphabetical order. Next, let us talk about an important class which is not included in your syllabus. You can call it as an additional information which will be useful for your competitive exam, which is called as what? Epoxy. Okay guys, now let us look after another important class of your ethers which are called as what? Epoxy. Do remember this epoxy is a type of your cyclic ethers. One of the type of our cyclic ethers. Cyclic ethers andre artha eno? Of course, ether ka functional group will be there. Oxygen oxy group will be there, but it will be in the cyclic form. It will be in the cyclic form. The general representation yav ತರ irutte epoxy du. The general representation of your epoxy is in this way. So two carbons will be attached to the oxygen and also with respect to each other. Then you will be having two other bonds which will be attached to other alkyl or the aryl groups. General ಆಗಿ ನೋಡಿ ಈ ಕಾರ್ಬನ್ ಹತ್ರ ನೋಡಿದಾಗಲೂ ಕೂಡ 1 2 3 4. What is that? Around this carbon also you are having 4 bonds. 1 2 3 4. And also around this carbon also you are having how many bonds? 1 2 3 4. So both the carbons tetravalence is satisfied. But what we are talking about, why it is called as an epoxy, you can just see the structure. So when I was writing for normally the ethers, how I was writing ROR. In this way I was writing. It was in a straight chain. But we can see over here it is in the cyclic form, like a cycle. It is like a cyclic form. Cyclic form. So they will be called as what? Cyclic ethers. This epoxy is very much important. We can say one of the most beautiful compound in organic chemistry. When you go for higher classes, many of the compounds will be related with this epoxy compounds. Okay. Just now for a while, we'll be just having some basic knowledge of this epoxy, that how to name this epoxy. So before naming this epoxy group, first we have to know, what do you mean by epoxy? So this is your epoxy, a type of your cyclic ethers where you will be having the general representation as what? COC, in which oxygen is bonded to these two carbons and also the two carbons are mutually bonded with each other, representing in a cyclic form. Okay, so first let us talk about the naming system. The naming system. So basically if I will be giving you certain important compounds over here, let us talk about how to name it. CH3, CH2, CH2 and a CH2. So here is now my epoxy group attached. Alva, idistu neglect madbidana ಈಗ ಕಾಣ್ತಾ ಉಂಟಲ್ಲ, ಇದೇ ರೀತಿಲೇ ಉಂಟು. ಇಲ್ಲಿ ಇದು ಬದಲು ಇಲ್ಲಿ ಏನು ಗ್ರೂಪ್ಸ್ ಬರ್ದಿರಲಿಲ್ಲ, ಅದ್ರ ಇಲ್ಲಿ ಏನಾಗಿದೆ H2 ಅಂದ ಗ್ರೂಪ್ಸ್ ನ ಕೊಟ್ಟಿದ್ದೀನಿ. ಅರ್ಥ ಆಗ್ತಾ ಉಂಟಾ? ಓಕೆ, I think I have made a mistake anyway. 1 2 3 4 1 2. Okay, 1 2 3. So here 1 H should be less, alva. 1 2 1 H 4. 1 2 3 4. So this is the part. Yes or no? So ಇದನ್ನ ಯಾವ ತರ ನೇಮ್ ಮಾಡೋದು? ರಿಮೆಂಬರ್, ಯಾವತ್ತೇ ಆಗಲಿ ನಾವು ಹೇಳಿದೀನಿ ethers are acting as what? As a substituent. So that should be get the lowest possible number. So 1 2 3 4. ಈ ಎಪಾಕ್ಸಿ ಯಾವ ಕಾರ್ಬನ್ಗೆ ಅಟ್ಯಾಚ್ ಆಗಿದ್ದೋ ಅದನ್ನ ನಾವು ಫಸ್ಟ್ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೋಬೇಕು ಅಲ್ವಾ. ಈ ಎಪಾಕ್ಸಿ ಇದು ಆಕ್ಸಿಜನ್ ಮೇಜರ್ ಅಲ್ವಾ, ಇದನ್ನೇ ನಾವೇನಂತ ಹೇಳಿದ್ದು ಆಕ್ಸಿ ಗ್ರೂಪ್. ಸೊ ಇದು ಯಾವ್ದಕ್ಕೆ ಅಟ್ಯಾಚ್ ಆಗಿದೆ? ಸೆಕೆಂಡ್ ಕಾರ್ಬನ್ ಮತ್ತೆ ಫಸ್ಟ್ ಕಾರ್ಬನ್ಗೆ. ಸೊ ವೆನ್ ಯು ಆರ್ ನೇಮಿಂಗ್ ಇಟ್, ಆಫ್ ಕೋರ್ಸ್ 1 2 within the bracket. Yes or no? 1 2 within the bracket. Then a hyphen. So what is attached at 1 2? The epoxy group. So epoxy alva 1 2 epoxy. Then normally the parental list carbon atoms into the root word and its primary suffix. That is 1 2 3 4. So epoxy butane. Are you getting my point? So what is the name of this compound? 1 2 epoxy butane. Let us talk about our second part. Yes. So here you are having CH3, CH2, CH2, and let me take here as a CH2. Yeah. So here let me give my oxygen attached. So no. So see whether this carbon tetravalence is satisfied. For this carbon you are having one bond, second bond, third bond, and the fourth bond is with hydrogen. So no. Also with this 1 2 3 4. So of course 1 2 3 4. Even you can come from this side also, you'll be getting the same numbering itself. So we got epoxy group yava eld carbon join agide? Yes, 1 and 3. So within this bracket 1 3, I have written the number. What is attached to that carbon? Epoxy alva, epoxy butane, epoxy butane. Are you noticing the changes? In the first case, of course, you are having the same number of the carbon atoms, but what we have written, the positions were changing 1 2. In the second, the position is changed as 1 3. Let us take now one more important part. The normal general epoxy group is in this way. CH, and over here you will be having as CH1 2 3 4 1 2 3 4. Are you getting my point? So of course 1 2. So how can I write it? 1 2 1 2 epoxy ethane alva, epoxy ethane. So in certain scenarios, since you are having only 2 carbon atoms, some of the cases we neglect this position, or directly you can write it as what? Epoxy ethane. Epoxy ethane. Are you getting the type, guys? How to name it? So epoxy means it's a type of a cyclic ether. General representation will be in this way. So these parts can be your alkyl, or even they can be your aryl, even they can be your hydrogens. So you have to first see, okay, we are having a cyclic ether over here. So this type of a compound will be called as what? Epoxy. Epoxy. First you have to represent their positions to which carbons they have been attached. Then you have to check out the number of the carbon atoms. Along with the root word, you have to write the primary suffix. Okay, now let me give you one important question, and you can just pause it and you can try by your own for a few seconds. CH3, CH, CH2, CH, let me give the epoxy group over here. Yep, in this way. CH, and over here is a CH2. Yes, can you please name this? So I am giving you 3 seconds. You can pause the video and you can just try it off. Okay, now let's just now we can only try it. Okay, let us just, how can we write this first? ಅಲ್ಲ ತುಂಬಾ ಕನ್ಫ್ಯೂಸಿಂಗ್ ಆಗುಂಟು. ಇಲ್ಲಿದ್ದಾಗ ನಾವು ಹೆಂಗ್ ನೋಡಿದ್ವಿ, ಆಕ್ಸಿಜನ್ ಗ್ರೂಪ್ ಮೇಲಿದ್ದಂಗೆ ನೋಡಿದ್ವಿ ಅಲ್ಲ, ಒಂದ್ ಸ್ವಲ್ಪ ಚೇಂಜ್ ಆದ್ರೂ ಕೂಡ ಆಂಬಿಗ್ವಿಟಿ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ. ಸೊ ನಮಗೆ ಇಷ್ಟ ಬಂದಾಗ ನಾವು ಬರ್ಕೊಳ್ಳೋಣ. ಆದ್ರೆ ಯಾವತ್ತೇ ಆಗಲಿ whenever we are writing, it should not change its original form. So how can we write it? CH3, okay, is there. CH is there. Of course, I will take the CH to down itself. CH. Since it has been bonded to the oxygen is bonded to this C and this C. So, like this. Yes or no? Okay. Then here you are having your CH and here you are having your CH2. So same form I have written. Instead of writing it down, I have written it up so that it should not be a confusion for me. Is that clear? Number it. 1, 2, 3, 4, 5, 6. Yes or no? If you're coming from the other side, what happens? The numbering becomes greater. We want always the least possible numbers. So 1, 2, 3, 4, 5, 6. So now what is your first task? If there was only one epoxy group, what I have done? Okay, first I have to write the numbers to which your epoxy group has been attached. So of course from here I am numbered. So first is my 1, 2. But one more epoxy group is there. So what I will do? Comma, yes, 3, 5. So 1, 2, 3, 5. I have got hyphen. So what are those? 1, 2 and 3, 5. What is there? Yes, epoxy. How many epoxy? Di-epoxy. Alva. So 1, 2, 3, 5. Di-epoxy. What is the next? 1, 2, 3, 4, 5, 6. Hexane. Are you getting my point, guys? So 1, 2, 3, 5. Di-epoxy hexane. So very much important. This epoxy, many times I have seen in the competitive exams they will be giving the structures by their name. So it should not be in ambiguity. Okay, please note it down on one side. So whenever you are reading your ethers part, you make a note for competitive exams and then have a note on the one side. So when you're reading for exam, that is your second PU board exam, no need of taking tension about these structures. But when you're preparing for your competitive exams, you have to know this important concepts. Is that clear? So we have come to know till now how to write for common names for your ethers, and we also came to know about how to write the nomenclature for epoxy. Yes or no? Can I consider it as an yes? Okay. Now let us go to the next important class, that IUPAC nomenclature. Very much important as a point of view with respect to your board exams and also for your competitive exams. So next let us look after the IUPAC nomenclature. IUPAC nomenclature of ethers. So guys, in the IUPAC nomenclature of ethers, you have to pay some attention. Okay. Simple task compared to that of your alcohols and phenols nomenclature. This nomenclature is somewhat simple, but you have to understand the major concept back. Okay. What is the concept while we are writing the IUPAC nomenclature for ethers? So as I have mentioned, whenever we talk about your ethers, we'll be having the representation as what? R, O and an R. So of course this R also contains some number of carbon atoms. This R also contains some number of carbon atoms. If it is in the case R is equals to R, it's not a big problem for us. But if R is not equals to R, that is if it is an unsymmetrical ether, so there is certain things we have to understand. Okay. First we have to understand, remember, whenever we are writing the IUPAC nomenclature, you remember, always they are named as an alkoxy derivatives. Alkoxy derivatives. Of what? Alkanes. So ethers are actually the alkoxy derivatives of alkanes. So when we are numbering it, or when we are naming it, instead of not numbering, we have to name it. So when we are naming it, remember, long chain attached to oxygen atom. Long chain attached to oxygen atom. Yes, it is called as a parent chain. What it is called as a parent chain. Similarly, the short chain containing oxygen. So along with oxygen, short chain containing oxygen, will be named as, I'll just say yes, and it will be named as respective alkoxy. ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಸಿಂಗ್ ಉಂಟು ಸರ್, ಅರ್ಥ ಮಾಡಿಸ್ತೀರಾ? ಆಫ್ ಕೋರ್ಸ್. ಸೊ ವಾಟ್ ವಿ ಆರ್ ಸೇಯಿಂಗ್, so when we are talking about the ethers, unsymmetrical ethers more particularly, do remember ಯಾವುದೋ ಒಂದು ಆಲ್ಕಿಲ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಕಮ್ಮಿ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಇರ್ಬೋದು, ಇನ್ನೊಂದು ಆಲ್ಕಿಲ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಜಾಸ್ತಿ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಇರ್ಬೋದು. ಸೊ ಆತರ ಒಂದು ಅನ್ಸಿಮೆಟ್ರಿಕಲ್ ಈಥರ್ಸ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ, ಯಾವ ಆಲ್ಕಿಲ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಜಾಸ್ತಿ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಇರುತ್ತೋ ಅದನ್ನ ನಾವು ಪೇರೆಂಟ್ ಚೈನ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಅದಾದ್ಮೇಲೆ ಯಾವ ಗ್ರೂಪಿಗೆ ಕಮ್ಮಿ ಆಲ್ಕಿಲ್ ಗ್ರೂಪ್ಸ್ ಇರುತ್ತೋ ಅಥವಾ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಇರುತ್ತೋ, ಕಮ್ಮಿ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಇರುತ್ತೋ ಅದನ್ನ ಆಕ್ಸಿಜನ್ ಸಮೇತ ಕನ್ಸಿಡರ್ ಮಾಡಿ ಆ ಒಂದು ಆಲ್ಕಿಲ್ ಗ್ರೂಪಿಗೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ರೆಸ್ಪೆಕ್ಟಿವ್ ಆಲ್ಕಾಕ್ಸಿ ಅಂತ ನೇಮ್ ಮಾಡ್ತೀವಿ. ಇನ್ನೂ ಕನ್ಫ್ಯೂಷನ್ ಉಂಟಾ? ಡೋಂಟ್ ವರಿ, ಲೆಟ್ ಅಸ್ check out certain examples. First one, let me take as CH3OCH3. Of course, this is a symmetrical ethers. In either side, the alkyl groups are containing only one carbon atom. But here also, we have to consider one as a parent chain, another as a alkoxy part. So what I will do, let me consider as this one as my short chain. I will consider them as a alkoxy and this one as my parent chain. So how can I write it? If it is an short chain, and this alkoxy ಇಂದ ತಗೊಂತಿದ್ದೀನಿ ಅಂದ್ರೆ ಮೆಥಾಕ್ಸಿ ಅಲ್ವಾ, ಇದು ಮೆಥೈನ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಅದನ್ನ ನಾನು ಬರೀ ಮೆತ್ ಅಂತ ತಗೊಂತಿದ್ದೀನಿ. Since it is having oxygen ಅಂತ ಉಂಟು, ಮೆಥಾಕ್ಸಿ. Remaining part unto, it is a parent chain, so methoxymethane. Are you getting my point? Methoxymethane. Yes. Similarly, second part, C2H5O C2H5. So of course this is also a symmetrical ether. So how can you name it now? Of course, now let me take this one as my alkoxy. So it is what? 2 carbon atoms. So eth. Oxygen is also attached. Ethoxy. This is my parent chain. So ethoxyethane. Ethoxyethane. Now let us take out unsymmetrical part. Let me take it as CH3O C2H5. Now comes the concept. What is that? Till now here it was an easy part. One methoxy methane, ethoxy ethane ಅಲ್ವಾ, ಆ ತರ ತಗೊಳ್ಳಿ. ಈಗ ನೋಡೋಣ, ಈಗ ಈ ಆಲ್ಕಿಲ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಕಮ್ಮಿ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಉಂಟು, ಈ ಆಲ್ಕಿಲ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಜಾಸ್ತಿ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಉಂಟು. ಸೊ ಈಗ ಪೇರೆಂಟ್ ಚೈನ್ ಯಾವ್ದಾಗುತ್ತೆ? ದಿಸ್ ವಿಲ್ ಬಿ ಮೈ ಪೇರೆಂಟ್ ಚೈನ್. ಹಾಗಾದ್ರೆ ಶಾರ್ಟ್ ಚೈನ್ ಆಗುತ್ತೆ ಇದು, ಬಟ್ ಇಟ್ ಇಸ್ ಆಲ್ಸೋ ಐ ಹ್ಯಾವ್ ಟು ಅಟ್ಯಾಚ್ ವಿತ್ ಆಕ್ಸಿಜನ್. ಸೊ ವೆನೆವರ್ ವಿ ಆರ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ದಿಸ್ ಶಾರ್ಟ್ ಚೈನ್, so that will be always taken as attachment with oxygen. So again anta name ಮಾಡಬಹುದು. First we have to name your short chain methoxy. ಆಯ್ತಾ? Then which is the parent chain? Ethane. So methoxyethane. Are you getting my point? Don't be panicked. You understand the concept. That's it. If I take as C6H5OCH3. ಸೊ ಇಲ್ಲಿ ತಗೊಂಡಾಗ ಇದೇನಾಗುತ್ತೆ, ಶಾರ್ಟ್ ಚೈನ್ ಯಾವ್ದೀಗ? ಇಲ್ಲಿ 6 ಕಾರ್ಬನ್ ಆಟಮ್ ಉಂಟು, ಇಲ್ಲಿ ಬರೀ ಒಂದೇ ಕಾರ್ಬನ್ ಆಟಮ್ ಇರೋದು. ಸೊ ನಾವು ದಿಸ್ ವಿಲ್ ಬಿ ದಿ ಶಾರ್ಟ್ ಚೈನ್. ಸೊ ಹೌ ಕ್ಯಾನ್ ಯು ರೈಟ್ ಇಟ್ ನೌ? ಎಸ್, ಮೆಥಾಕ್ಸಿ ಅಲ್ವಾ, ಮೆಥಾಕ್ಸಿ. ಫಸ್ಟ್ ದ ಶಾರ್ಟ್ ಚೈನ್ containing the oxygen named as what? Alkoxy, respective alkoxy. ಇಲ್ಲಿ ಆಲ್ಕಿಲ್ ಯಾವ್ದು? ಇಲ್ಲಿ ಮೆತ್. ಸೊ ಮೆಥಾಕ್ಸಿ. Parent chain is benzene. So methoxybenzene. Are you getting my point, guys? Don't get confused. First check ಮಾಡಿ ಯಾವ್ದಕ್ಕೆ ಕಮ್ಮಿ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್, ಆ ಕಮ್ಮಿ ಕಾರ್ಬನ್ ಆಟಮ್ ನ ಶಾರ್ಟ್ ಚೈನ್ ಅಲಾಂಗ್ ವಿತ್ ದಿ ಆಕ್ಸಿಜನ್ ನಾವು ಬರೀಬೇಕು. ಓಕೆ, ಮೆಥಾಕ್ಸಿಬೆನ್ಝೀನ್. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ಈ ಒಂದು ಕಾಮನ್ ಎಕ್ಸಾಂಪಲ್, ನಾನು ಸೆಕೆಂಡ್ PUC ಇದ್ದಾಗ ನಂಗೆ ಒಂದು ಡೌಟ್ ಬಂದಿತ್ತು, ಅದನ್ನ ನಾನು ನಿಮಗೆ ತೋರಿಸ್ತೀನಿ. ಓಕೆ ಸರ್, ಇಲ್ಲಿ 6 ಕಾರ್ಬನ್ ಆಟಮ್ ಇತ್ತು, ಬೆನ್ಝೀನಿಗೆ ಇಲ್ಲಿ ಒಂದೇ ಕಾರ್ಬನ್ ಆಟಮ್ ಇತ್ತು. ಈಗ ನಾವು ಒಂದು ಕೆಲಸ ಮಾಡೋಣ, ಇಲ್ಲಿ ನಾನು ಬೆನ್ಝೀನ್ ಬರೀತೀನಿ. C6H5. C6H6 ಅಲ್ವಾ? ಈಗ ಇದು C6H5 ಆಯ್ತು. ಇದನ್ನ ನಾನು CH2 7 times ಅಥವಾ 6 times CH3. ಈಗ ಏನ್ ಮಾಡ್ತೀರಾ? Of course, here when we saw what we saw, this was having 6 carbon atom, this was having 1 carbon atom. But this is not the case over here. For this side, we are having how many carbon atoms? 6 carbon atoms. But on the next side, how many carbon atoms? 6 plus 1, 7 carbon atoms. So now this will be your parent chain and this will be our short chain along with the oxygen. So phenyl is there, oxygen is there. So how can you write? Phenoxy. Phenoxy. Then of course the parent chain, totally 7 carbon atoms, heptane. Are you getting the difference, guys? So always the short chain should be written as what? Respective alkoxy. Since here only 6 carbon atoms was there, I have taken this one as a short chain, which is along with the oxygen will be called as what? Phenoxy. Then the normal parent chain is will be a heptane. So phenoxy, heptane. Are you getting my point? Okay, let us solve some important now class. Somewhat complex examples. CH3O. Then I can take CH2, CH, CH3, and over here let me take it as an OET. ನೋಡಿ ET ಅಂತ ಉಂಟು ಅಂದ್ರೆ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ, ಇಟ್ಸ್ ಅನ್ ಈಥೈಲ್ ಗ್ರೂಪ್ ಅಂತ. CH2 CH3 ಈ ತರ ಅಂತ. ಸೊ ಈ ಇಡೀ ಗ್ರೂಪ್ ನ ನಾವು ಕೆಲಸ ಏನಂತ ಹೇಳ್ತೀವಿ? ET. ET means ethyl. These are the common things one has to know in your organic chemistry. So what we are observing over here, yes, we are having 2 ether groups alwa. ಈ ಕಡೆನೂ ಒಂದು ಪಾರ್ಟ್ ಉಂಟು, ಈ ಕಡೆನೂ ಒಂದು ಪಾರ್ಟ್ ಉಂಟು. So I will give you 5 seconds. You just try it how we can name it. ಯಾವ್ದನ್ನ ಪೇರೆಂಟ್ ಚೈನ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಬೇಕೀಗ ಅಲ್ವಾ? ಸೊ ನಾವು ದಿಸ್ ಪಾರ್ಟ್ ಓನ್ಲಿ ವಿಲ್ ಬಿ ಮೈ ಪೇರೆಂಟ್ ಚೈನ್. ಸೊ ದಿಸ್ ಇಸ್ ದಿ ಪೇರೆಂಟ್ ಚೈನ್. ಈಗ ಇದನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? ಇಷ್ಟಕ್ಕೆ ಜಾಸ್ತಿ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಉಂಟು. ಇದನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? ಇಲ್ಲಿ ಬರೀ ನೋಡಿ CH2 CH3 ಎರಡೇ ಇರೋದು, ಇಲ್ಲಿ 3 ಭಟ್ ಉಂಟಲ್ವಾ? ಸೊ ದಿಸ್ ಮಚ್ ವಿಲ್ ಬಿ ಮೈ ಪೇರೆಂಟ್ ಚೈನ್. ಸೊ ಅಫ್ ಕೋರ್ಸ್ ನಾವು 1 2 3. ಸೊ ನಾವು 1 2 3. So ಏನಾಗುತ್ತೆ? This will be called as what now? Ethoxy. This will be called as what? Ethoxy. This will be called as now what? Methoxy. So ಯಾವ್ದು ಫಸ್ಟ್ ಬರ್ಬೇಕು alphabetical order ಪ್ರಕಾರ? M E na. So first comes E along with its position. I'll write it over here. 2-ethoxy. ಬರೀಬಹುದಾ? 2-ethoxy. Then -3-methoxy. Then normal parent chain propane. Are you getting my point? So this is the way of writing. So 2-ethoxy, 3-methoxy, propane. Now let us take somewhat more complex. ಇಲ್ಲಿವರೆಗೆ ಬರೀ ಈಥರ್ ಇತ್ತಲ್ಲ, ಈಥರ್ ಮಧ್ಯದಲ್ಲಿ ಈಗ ಎಪಾಕ್ಸಿ ಗ್ರೂಪ್ ನು ಹಾಕ್ತೀನಿ, ಸೈಕ್ಲಿಕ್ ಈಥರ್ ನು ಹಾಕೋಣ ಅಲ್ವಾ? ಹಾಕಣ್ವೆ. ಸೊ how can I write it, guys? CH3, just guide me in case if I am just missing the valency for the carbon. CH3CH, CH, I'll give here itself epoxy. Then I will give as CH2OCH3. Yes or no? So now this is one type, this is another type. So this is an unsymmetrical ethers. So now according to this one, this is having the larger number of carbon atoms. So overall now this part will be your parent chain. Yes or no? So 1 2 3 4. So how can you name it now? 2-3, yes, hyphen epoxy alva. 2-3 epoxy hyphen 1. This is now what? Alkoxy. Methoxy, butane. Getting my point? How we are writing it? Of course, alva E first bar epoxy. ಇದಕ್ಕೆ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ? Epoxy ಅಂತ ಹೇಳ್ತೀವಿ. ಇದು methoxy ಅಂತ ಹೇಳಿ. ಯಾವುದು alphabetical order ಪ್ರಕಾರ E first ಬರಬೇಕು. So the first now represent the number na first represent 2, 3 epoxy 1 methoxy butane. Do remember, those who are getting confused, you please don't refer now these parts. Okay, it is only for a few of the students whom they think that they can manage it. Of course, I have given certain simple examples in the notes. That much is enough for your PU board exam. But in order to solve certain competitive exams, such names are very much important. For that is the reason I don't want from my side any loophole. Is that clear? For that is the reason I'm just giving my best in these examples. Okay. Let us take now one more. CH3 OCH CH3, and here is my CH3. Remember guys, like this, if any compound is there, of course now what happens, this is my short chain, this is my longest chain alwa, this is my longest chain. So iduna number madase, remember we'll number from here 1 2 3. Getting my point? So our reason in the this will be now what, adding as a substituent. Now ಹೇಳಿದ್ದೆ ಈ ತರ ನಾವು ಏನಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, substituent ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. So ಇಡೀ substituent ಯಾವ ಕಾರ್ಬನ್ ಆಟಮ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ? Yes, so this will be called as what? 2-methoxy propane. 2-methoxy propane. Why I am saying this? If the same thing is seen in this way, CH3O, if I take as a CH2, CH2, CH3. So of course now this part will be what? Yes, now this will be your alkoxy alwa. This is your longest carbon atoms. So this will be 1-methoxy propane. 1-methoxy propane. Why? Because I'll number from here 1 2 3. Numbering yavatte agli parent chain ge tane ನಾವು number ಮಾಡೋದು. ಇಲ್ಲಿ ಇದು parent chain, longest chain rule. So ಇಲ್ಲಿಂದ number start ಆಗುತ್ತೆ ಅಲ್ವಾ, ಅಥವಾ ಇಲ್ಲಿಂದ ಬೇಕಾದ್ರೂ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ. ಯಾವುದೇ ಪೊಸಿಷನ್ ಇಂದ ಮಾಡಿದ್ರು ಕೂಡ ಸೆಕೆಂಡ್ ಕಾರ್ಬನ್ ಗೆ ನಮ್ಮ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಅಟ್ಯಾಚ್ ಆಗಿದೆ. ಸೊ ಅದನ್ನ ನಾವು ಇಂಡಿಕೇಟ್ ಮಾಡಬೇಕು. ಇಫ್ ಇಟ್ ಇಸ್ 1-methoxy propane also you can write, or in some cases we can also write it as what? Just methoxy propane. But it is only possible when the substituent is attached to the first carbon. Yes, let me check out now one more important part. CH3O CH CH2 CH3, and here is my CH3. So how will you first see this, which is your short chain? Of course, this is my short chain, so it will be named as what? Respective alkoxy. So now this is my substituent. How will you number it? Yes, so the carbon containing the substituent should get the least number. So 1 2 3 4. So now how will you write it? 2-methoxy. How many number carbon atoms are present in the parent chain? 4. So 2-methoxy butane. Are you getting the differences? How we are writing it? Very much important to generate. ಅದೇ ರೀತಿ ನಾನು ಸ್ಟ್ರೇಟ್ ಚೈನ್ ಬರ್ತೀನಿ, ಏನಾಗೋದು CH3O CH2 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 CH3. Of course now this will be my substituent alkoxy. ಇಲ್ಲಿಂದ ನಂಬರ್ ಮಾಡಿ 1 2 3 4. So this can be called as what? 1-methoxy butane. Able to notify the changes. So where your substituent ಈ ತರಿನ alkoxy ಎಲ್ಲಿಗೆ ಅಟ್ಯಾಚ್ ಆಗಿದೆ ಆ ಕಾರ್ಬನ್ ಆಟಮಿನ ನಂಬರ್ ನ ಇಂಡಿಕೇಶನ್ is very much important, and it also depends how you number it. Whatever the alkoxy derivative is there, remember they are acting as a substituent. Of course we know what, whenever a substituent is present, that carbon atom should get the least possible number, and also we have to indicate that number in the IUPAC nomenclature. Getting my point? So these are certain examples for IUPAC system, which is very much important for your competitive exams and also for your board exam. Coming to the another concept, as I have mentioned, next let us see concept which is important for competitive exams, the naming of cyclic ethers. A type of a cyclic ethers we saw, which is called as what? Epoxy. But now we have to see that there are also many other types, and we have to understand how to name those cyclic ethers. And do remember, it's an additional information important for our competitive exam point of view. So guys, now when we talk about the cyclic ethers, first we have to understand what do you mean by this cyclic ethers. So basically, cyclic ethers means these are the compounds in which oxygen will be a part of the ring. Will be a part of the ring. So basically we have seen a type of a cyclic ether which was called as what? Epoxy. So basically that epoxy was the nomenclature which was including with respect to the common names. So generally we will be calling the epoxy groups in the common names. But in this presentation, in this part, we are going to see that how we are going to name the cyclic ethers according to the IUPAC names. So in order to understand that part, first and the foremost thing, we have to understand two important things. What is that? So whenever we are giving the IUPAC nomenclature of your ethers, we will be adding in that IUPAC name one thing which will be a constant, will be an oxo. In the name we will be having this term as an oxo. And whatever the remaining part will be added, that will be a suffix. That will be a suffix. Overall, this suffix depends upon the number of the atoms present in the ring. Number of the atoms present in the ring. So depending upon the number of the atoms in the ring, IUPAC has given certain names. First let us see those names. And do remember, number of atoms. I am not saying any particular atom. Overall in the ring, what are the number of the atoms? Depending upon that part, we will be adding the suffix. Okay. First let us check out, let me take a table, number of atoms in a ring. Okay. And let me take over here as a suffix. Okay. So now, if the number of the atoms in a ring is 3, I repeat, if the number of the atoms in a ring is 3, then I would be using my suffix as irane. Irane, I-R-A-N-E. If the number of the atoms in a ring is 4, then I would be using my suffix as ethane. Ethane. If the number of the atoms in a ring is 5, I would be using the suffix as lane. Lane. If it is 6, then it will be called as an ane. This much is enough for your level. Okay. So number of the atoms in a ring is 3, means it will be given a suffix as irane. So oxo admele irane anta add madkontivi. If the number of the atoms in a ring is 4, the suffix uses ethane. So after oxo, I will be using ethane. If it is 5, lane. If it is 6, ane. Remember, when you are writing the name, this O can be eliminated, or we will not write it when the added suffix word is starting with a vowel. Similar as we have seen in the IUPAC nomenclature. Nodidvalva? Yavatte agli ಒಂದು ನಮ್ಮ suffix add ಆಗತ್ತಿಗೆ ಅದರ vowel start ಆಗ್ತಾ ಉಂಟು ಅಂತ ಆ ಹಿಂಗಡೆ ಲೆಟರ್ ನಾವು ಎಲಿಮಿನೇಟ್ ಮಾಡ್ತೀವಿ. The same concept. Let me give now one common example. Epoxy ನೋಡಿದ್ವಲ್ಲ ಅದನ್ನೇ ತಗೊಳ್ಳೋಣ. CH2. So okay, CH2 ಈ ತರ ಉಂಟು. So ಎಷ್ಟು overall ಇದು ಒಂದು ring. So this ring ಅಲ್ಲಿ ಎಷ್ಟು number of the carbon atoms ಉಂಟು? This is one atom ಅಲ್ವಾ? One oxygen atom, 2 carbon atoms. So total number of the atoms in the ring is how much? 3. Yes or no? So first what I should write? Ox ಅಂತ ಬರೀದು. ಆಕ್ಸೋ ಅಂತ ಬರೆಯ ಬದಲು ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಉಂಟು, ನನ್ನ ಸಫಿಕ್ಸ್ ಅಲ್ಲಿ ಐ ಲೆಟರ್ ಬರ್ತಾ ಉಂಟು. ಸೊ ಇಟ್ ಇಸ್ ಅ ವೋವಲ್. ಸೊ ಓನ ಎಲಿಮಿನೇಟ್ ಮಾಡಿ ಏನ್ ಬರೀಬಹುದು? ಆಕ್ಸ್ ಇರೇನ್. ಸೊ ಎಪಾಕ್ಸಿ IUPAC name is what? Ox irane. So let us check out now one more part. CH2O, CH2, CH2. So now here you are having one oxygen is there. Of course now it's a cyclic ether. But total number of the atoms in the ring is how much? 1, 2, 3, 4. So first what is my duty? I should write oxo. But I have to check out. Okay, it is also starting with a vowel letter. So ox ethane. Ox ethane. Ox ethane. E-T-A-N-E. Yes or no? Check out now 5 membered CH2, 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 and over here as O. 1, 2, 3, 4, 5. So what we will do now? Ox. Its number name starting with a consonant alva L. So oxo and the complete agbardi, then lane. Oxolane. Getting my point? If it is 6, 6 you can only write, I hope. Alva benzene ring ರೀತಿಲೇ ಬರ್ಕೊಂಡಲ್ಲ, hexane ring ಅಂತಾನೆ ಬರ್ದಿ ಇಲ್ಲಿ O ಅಂತ ಹಾಕ್ಬಿಡೋಣ. ಅವಾಗ ಇಲ್ಲೂ ಕೂಡ CH2 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 and CH2. Getting my point? So what it will be called as is oxo ಅಂತ ಬರುತ್ತೆ. ಅದರಲ್ಲಿ A sound ಉಂಟು, so oxane. Oxane. So this is the way of writing the IUPAC name for your cyclic ethers. Okay, it's an additional information. If you think it is needed, you can make a note of it. Very much important concept. But according to your PU syllabus, it is not included in your syllabus. But for your competitive exams, they can ask. Is that clear? Okay. So in today's video, we have seen about the ethers. Classification of the ethers. We came to know there are two important classes. One is called the cyclic ethers. One is called your symmetrical ethers and another your unsymmetrical ethers. So in your symmetrical ethers, we came to know alkyl or the aryl groups on either side of the oxygen will be same. In your unsymmetrical ethers, the alkyl or the aryl groups will be different. Then we came to know about the nomenclature. First we studied about your common system, how to name it. Then we see about a most important class which is called as what? Epoxy group. Then we came to know about your IUPAC nomenclature. And mainly in IUPAC nomenclature, we have mainly focused that whenever you're having the two different groups attached to your oxygen, then first the smallest part will be written as an alkoxy. The larger carbon chain will be taken as a parent chain. So depending upon that one, we'll be writing as an alkoxy alkenes. In that way, in that manner, we will be writing. Is that clear? Then we came to know about a cyclic ethers. So whenever we are naming your cyclic ethers, first important thing we have to know that what is the total number of the atoms which will be present in your ring. I repeat, number of the atoms. We are not saying any particular atom. Overall ಆ ಒಂದು ring ಅಲ್ಲಿ ಎಷ್ಟು atoms ಇರುತ್ತೆ ಅನ್ನೋದನ್ನ important ಆಗಿರುತ್ತೆ. So depending upon number of the atoms in the ring, we will be having the suffix. So depending upon that suffix, we are having the IUPAC has given certain names. So whenever you are writing an cyclic ethers, first you have to write as an oxo and then you have to add that suffix. But if the suffix word is starting with a vowel, then you have to eliminate from the oxo the last O and you just add it. So that will be giving the name of the ethers. Is that clear? So in today's video, we have completely known that how to write or how to name the ethers both in the common system and also in the IUPAC system. Then in next video, we are going to see the preparation of ethers. I repeat, in the next video, we are going to see what? How can we prepare ethers? Okay.